period of a spring mass system. Here I have a depiction of a spring mass system. If I was to take this mass and pull it down, it would oscillate up and down. Now, the movement from the original position to the far position back to the original position, we consider that one complete cycle. And the time it takes to go from here back to the original position, we call that the period of time of one cycle. So period, capital T, is equal to the time of one cycle, or one round trip. Period is measured in seconds. We can also measure it in hours or days, but the SI unit is the second. Now you'll notice in the formula, TS spring, the period of the spring, is equal to 2 pi times the square root of the ratio m divided by k. M is the mass hanging from the spring, and k is the stiffness of the spring, or the spring constant. That means that this relationship shows that the period is directly proportional to mass. So if I increase mass, I'm going to increase the period. So a heavier mass will slow the time of movement. Now, if I increase the stiffness of the spring, the movement could go much faster. Now, the pi in the formula suggests that the motion is cyclical. So this is somehow related to circular motion. So that I'm going to explore in a separate lesson. So since period is equal to 1 over frequency, we can substitute that and change the formula from in terms of period to in terms of frequency. So the substitution leads to this formula where the frequency of the spring vibration is going to be equal to 1 over 2 pi times the square root of the ratio of k over m.